So we're going to be looking at the amount of insulin in a body. So a patient who is diabetic receives 100 micrograms of insulin. The graph shows the amount of insulin in micrograms remaining after 0 minutes. So if you look, our initial value, which is not labeled, would be 0 minutes. We have 100 micrograms of insulin. So scientists have found that the amount of insulin in a patient's body changes exponentially. So how can you check if the graph supports the scientist's claim? So what you can do is this. So first, we know our initial value is 100 micrograms. Now, to get our growth, or in this case, it's going down, so our decay factor, we have here 2 points that are right next to each other. So what we can do is take the y value here from the second point and divide it by the y value from the first point. So what I'm going to do is just put y2 divided by y1, which in this case, our second y value is 90 divided by 100. And you could write that as a fraction. So you could put our decay factor b is 9/10. Or if you're a decimal person, you could put 0.90. So in looking at that, we could make an equation. And test it. So to test our equation, what we could do is our equation now would be y equals 100 times 9/10 to the x. So what I'm going to do is check, does that work for 2 minutes and 3 minutes? So to put that in my calculator, I would go 100 times in parentheses, 9 divided by 10, close the parentheses and raise that to the second power, and we get 81. And now I'll check for the third minute too, so I can hit second entry and go to the third power. And we get 72.9. So our equation is correct. Here, how much insulin broke down in the first minute? Well, we went from 100 to 90. So we lost 10, if I'm looking for the units here, micrograms. And then what fraction of the original insulin is that? So here, if we're looking at that, if we lost 10 micrograms out of the original 100, that is 10% lost, which remember though, our growth factor, or in this case, the K factor, is how much do you keep? So that means we keep or retain 90% of the insulin value is kept. And then here, how much insulin broke down in the second minute? So from here, we went from 100 to 81. Or in the second minute, we went from the first to the second, we could look at that as losing 9. So from the minute before, we lost 9 more. So 9 micrograms lost in that from the first minute to the second minute. What fraction is that from 1 minute later? So again, that would be in this case 9 out of 90, which is 10% lost, which again, remember if we lose 10%, that means you keep 90%. So now, what fraction of the insulin remains in the bloodstream? Well, we just talked about that. If you lose 10% from the bloodstream, you keep 90% because there's a total of 100%. So to explain that, if you lose 10%, you keep 90%. And I'm going to put down here because 90% plus 10% is equal to 100%. So now to keep this, to fill in this table, I'm going to use the equation. So again, we have 100 times 9/10, and I'm going to put to the fourth and to the fifth power. So on here, if you press second, enter, and then go back, and then if we go here to the fourth minute, we're at 65.61 micrograms. Then if I go back and hit the second entry, for 5 minutes, I'm at 59.049. I'm going to round that to 2 decimal spots and call that 59.04. If you were to type in this value and keep going, you would have some round off error from rounding to the 10th spot. Whereas if you keep the equation, you're going to minimize the round off error that you use. So describe how you would find how many micrograms is in his bloodstream after 10 minutes. So after 10 minutes, we can use that equation. Y equals 100 micrograms times 9/10 to the 10th. So again, to describe that, just say use the equation. And now let's answer that. And that would be 38.74. And then in general, for m minutes, we would just change this from x to m. So y would equal 100 times 9/10 to the m.